The last lesson in week 13 talks about ratios of similarity. And so we talk about how perimeters and areas of similar figures are related. Similar figures are figures that have the same shape. So it's like two rectangles, this one's just a little bit smaller, two triangles, things like that. Two shapes that have the same shape, but maybe not the same size. So let's look at these shapes below, and we're going to calculate the areas and perimeters to complete the pattern. Well, first of all, I see that this is 15 and this is 25. So my small figure is 15, my large is 25, and I can reduce that by 5 to 3/5. So this is the ratios of my side. So it's 3/5. So if I need to find this missing side right here, well, I already know the ratio is 3/5. So I'm going to take my ratio, 3/5, and notice everything about my small figure is on top, everything about my large figure is on the bottom. I know that this side is 6. This side corresponds to this missing side. I'll call it x. And I'm going to now solve for x. We're going to do cross products, back to cross products. 30 equals 3x. Therefore, x equals, divide both sides by 3, x equals 10. So we know that this is 10, this is 10, this is 25, this is 6, this is 15. So to find the perimeter of the small shape, I'm going to add everything up. So perimeter of the small is 15 and 15 is 30, 6 and 6 is 12. So I add those two together and I get 42. And for the large figure, 25 and 25, perimeter of the large, I'm going to add 25 and 25, I get 50. 10 and 10, I get 20, so I get 70. And I can reduce that. What goes into both 42 and 70? How about 7? We get 6/10. And I can reduce that even further by 2, and I get 3/5. Oh, look at that. The ratio of the perimeters is the same as the ratio of the sides. That makes sense because the perimeter, we're just adding up the side lengths, and they're not changing. Okay, and let's look at the area. The area for the small figure, that's going to be 6, so base times height for a rectangle, right? So base times height, so we're going to get 6 times 15, that's 90. And the area of the large figure is 25 times 10, which is 250. And I can reduce that. If I reduce it by 10, I get 9/25. And I can't reduce it anymore, so it's just 9/25. So the area has a different ratio than the perimeter, but the sides and the perimeter is the same. The area is different. I wonder if there's a relationship between 3/5 and 9/25. Let's look at the next figure. I already wrote in here this is 12 because I was figuring it out before we got together of how to explain it to you. So I'm going to find this missing side. I'm going to use the fact that I have this 60 degrees is given to me. I have, if I label the hypotenuse, the opposite, and the adjacent, I see, remembering way back when to trig functions, I have the adjacent and I have the hypotenuse. So if we use SOHCAHTOA, adjacent and hypotenuse is cosine. So I have cosine of 60 degrees equals opposite over hypotenuse. Set this up over 1 and let's do cross products. 6 equals h times cosine of 60. Divide both sides by cosine of 60. So I'm going to take my calculator, or you can go to Desmos. Desmos is probably easier. 6 divided by cosine of 60, and that gives me 12. My answer is 12, so I wrote a 12 in there. Okay. And then I need this side over here. I'll just go ahead and do the same thing. I now need the opposite. I'll do it in a different color. I now need the opposite, and I can either use the 12 or the adjacent. I guess I was given this one, so I'll use this one. What do I do when I have opposite and adjacent? That's tangent of 60 equals, we'll call this y, y over 6. Okay, again, we're going to set up cross products, and we're going to get y equals 6, tangent 60. So we're going to go to our calculator. We're going to type 6 tangent 60, and we get 10.39. Let's just change that to 10.4. Okay, let's just round it to 10.4. Okay, so now I can compare the sides. Okay, and I see that the hypotenuse of this one is 4, and the hypotenuse of this one is 12. So if I do 4 over 12, that reduces to 1/3. Okay? My perimeter of the, I'm going to do perimeter of the large first, is going to be 12 plus 6 plus 10.4. That's 18. 12 plus 6 is 18, plus 10 is 28.4. So 28.4 is my perimeter of the large. Now the small figure, I need to know what all these different sides are. I already know I have a ratio of 1 to 3. So to set up that ratio, let's go 1 over 3 equals, now I don't know what this little side is right here, but it corresponds to this side right here. I'll call this x. I'm looking for the x on the small. Everything about my small figure is on the top. And over 6. And we're going to multiply across. We get 3x equals 6, or x equals 2. So I know that this side is 2. And now I need to know this side over here. I'm going to come over here where there's a little bit of space. 1 over 3 equals something. We'll call this y over 10.4. So we're going to multiply. 3y equals 10.4. And let's come over here and go 10.4 divided by 3 equals 3.46. We'll round it to 3.5. 3.5. So now when I do the perimeter of the small, I'm going to do 3.5 plus 2 plus 4. So we're going to get 4 plus 2 is 6, 7, 8, 9.5. 9.5. So what is that ratio? What is 9.5 divided by 28.4? Oh, 0.33, right? And it's a little bit off because we rounded, but you can see it's 0.333. So 0.33, okay, which is really 1/3, okay? And just to prove it to you, let's go like this. 1 divided by 3 is 0.333. So our perimeters and our sides are going to have the same ratio. Now, the reason this didn't come exactly out as 0.333 repeating forever is because we rounded these decimals right here. But if we just keep, we're going to estimate that it's 1/3. Let's look at the area, okay? The area of a triangle is 1/2 base times height. So the area of this triangle is 1/2, the small one, 1/2 of 2 times 3.5. So 1/2 of 2 times 3.5. This is the area of the small. 1/2 of 2 is 1. 1 times 3.5 is 3.5. And let's do the large. 1/2 area of the large is 1/2. The base is 6, and the height is 10.4. So we're going to go 1/2 of 6 is 3. 3 times 10.4 equals 31.2. 31.2. And so what is 3.5 divided by 31.2? We get 0.111, which I'm going to tell you right now is going to be the same as 1 divided by 9, 0.111. So it's not the best example because things didn't work out pretty. But again, notice our ratios, right? The ratio of the perimeters and the ratio of the sides are the same, and then there must be some kind of relationship between the perimeter and the area. Do you see it yet? Let's keep going. Let's look at the next one. Okay, the ratio of the sides. Well, I'm going to look at the sides, and I get the sides is 5 over 40, which reduces to 1/8. The perimeter, so if this is 5, 5, 5, and so this is going to be 40, and this is going to be 40. If my ratio is 1 over 8, we're going to find this missing side right here. I'll call it x. 1 over 8 equals 13 over x, because everything about the large figure goes on the bottom. So we're going to multiply cross products. X equals 13 times 8. And 13 times 8 equals what? Let's go over here. 13 times 8 equals 104. So this is 104. So the perimeter, let's add up the perimeter. The perimeter is going to be 5, 10, 15 plus 13. 15 plus 13 equals 28. And then the area, the perimeter of the large, so perimeter of small, perimeter of the large, 40 plus 40 plus 40 is 120 plus 104. That's going to be 224. 224. Well, what is 224 divided by 28? I bet you it's 8. Yep. So when we reduce this, we get 1 over 8. Well, remember we talked about ratio of the sides and the ratio of the perimeters is the same. Let's look at the area. Well, the area of a trapezoid is 1/2 base 1 plus base 2 times the height. So if I'm going to do the area of the small trapezoid, it's going to be 1/2. The bottom base is 13, the top base is 5, and then the height is not 5. I have to figure out this distance right here. Okay, so let's see. This is not going to be, okay, why don't we make this easy? Okay, if this is 5, then this is 5. 13 minus 5 is 8, so that means this is going to be 4 on this side and 4 on this side. I want to know this distance right here. I'll call this x. And we are going to apply the Pythagorean theorem. 4 squared plus x squared equals 5 squared. Or you could see this is a 3, 4, 5, but let's go ahead and solve this. Equals 25. 4 squared is 16. 5 squared is 25. When we subtract 16 from both sides, we get 9. When I take the square root, I'm going to get positive or negative 3. Since we're talking about length, it has to be 3. Because I can't have a negative height. I'm going to come back over here and I'm going to see my height is 3. So this is going to be 1/2 of 18 times 3. 1/2 of 18 is 9. 9 times 3 is 27. So there's a 27 there. Now, whoa, we got to figure out the area of the large one. 1/2 of the, go through the formula. Base 1 is 40. The other base is 104. So I'm going to add those together. Times the height. Oh, I'm going to have to figure out the height again. So again, if I cut this off, this is 40, and I'm going to take 40 away from 104. I get 64. Let me divide that in half. I get 32. So this side is 32. So we're going to do 32 squared plus something squared equals 14 squared, or 40 squared. 32 plus x squared equals 40 squared. This is 1600. What's 32 squared? 32 times 32 equals 1024. Subtract that from 1600. It's going to be, should be positive. It's going to be, sorry. What was that again? It was 1128. 32 times 32 equals, 1024 plus x squared. Subtract 1024, you get 576. And what is the square root? There's a lot of work on this one. What is the square root of 576? I believe it's 24. So we're going to get x equal to 24. Okay. I did all of that just for the height over here. Okay. So we're going to get, okay, I paused and did a little bit of math. So we found out x was 24. I plug in 24 for my height. And I do half of 144 times 12 is 1728. So we get the area is 1728. If I reduce this, if I divide both sides by 27, I get 1 over 64. So again, let's look at the ratios. How are the perimeters and how are the perimeters of similar figures related? Okay, the perimeters, it has the ratio is same as the sides, and on this next one you're going to find out in the next video how they're related.